Hello students, we are discussing integration by partial fraction. Let's have a look at the question in this particular module. It says evaluate the integral x square plus 2 upon x minus 1 into x plus 2 into x plus 3. Correct? Let's see the solution. Now my dear students, I can very well see from the question that the conditions of partial fraction are satisfied. Let's quickly have a look at that. If I say the first condition, degree of numerator is 2, degree of denominator is 3, because I have 3 brackets there, multiplied, each of them having power of x as 1. So can I say first condition is satisfied? Likewise, if you see, there are 3 brackets in the denominator, none of them have the same terms, so I can say distinct linear terms are present. Correct? So both conditions are satisfied. Let us apply the partial fraction. I am not writing the question in this case. I'll directly write the partial form, which says let x square plus 2 upon x minus 1 into x plus 2 into x plus 3 is equal to. Now because we have 3 brackets, my dear students, we'll have 3 constants a, b and c. Let us write that a upon x minus 1 plus b upon x plus 2 plus c upon x plus 3. Now my dear students, instead of 2 constants we have to find 3. The method does not change. We will take LCM. So we will write x square plus 2 is equal to. Now when I take LCM, a will be multiplied by 2 terms, precisely x plus 2 and x plus 3. Likewise, b will be multiplied with x minus 1 and x plus 3, and c will be multiplied with x minus 1 and x plus 2. Now my dear students, to find a, I have to make both b and c 0. Now b and c should be 0 means their coefficients should be 0. How to make coefficient of b and c 0? Now my dear students, there are 2 ways to go about it. Find the common terms to b and c. If you see, x minus 1 is common. So if x minus 1 is common, put x is equal to 1, their coefficients will become 0, b and c disappear from the equation. Correct? So what do we get? We get 1 plus 2, that is nothing but 1 plus 2 on the left hand side, and the right hand side will be a into bracket 3, or 1 plus 2 into 1 plus 3. So that is 3 is equal to a into 3 into 4. That is nothing but a is 1 by 4. On cancelling the 3, I get a is 1 by 4. Is that okay, my dear students? Also, my dear students, you observe the denominator of a is x minus 1. Where does x minus 1 become 0? Add x equal to 1. So when you put x is equal to 1, you get the value of a. So just look at the denominator, where it becomes 0, that value you should substitute to get that particular constant. Now let's go ahead to find b. Denominator of b is x plus 2. So I should put x is equal to minus 2. Let's verify that. Now if you see, a and c should be 0. They have x plus 2 in common. So I'll put x is equal to minus 2. Let's substitute that. So we get 4 plus 2 is equal to b into brackets minus 3 into 1. Can I say that? Correct? So can I say b is minus 2? Because that's 6 upon minus 3. That's minus 2. Now let us take the value of c. To find c, I will put x is equal to minus 3. Put x is equal to minus 3, we get 9 plus 2 is equal to c into brackets minus 4 minus 1. So can I say c is nothing but 11 by 4. Correct? Now my dear students, we've got the value of a, we've got the value of b, we've got the value of c. All the constants which were supposed to be found out are done. Let's go to write the partial form. Now my dear students, for the partial form, this is what we had. Now let us substitute the values of a, b and c. Now the left hand side first let me write, that is x square plus 2 upon x minus 1 into x plus 2 into x plus 3 is equal to a upon, let's recall the values, a is 1 by 4. So shall I write 1 by 4 upon x minus 1? Correct? Likewise b upon, that is nothing but minus 2 upon x plus 2, and c upon, that is nothing but 11 by 4 upon x plus 3. Now my dear students, the product there is converted into addition. So integration becomes very easy. So let's write that 1 by 4 integral of 1 upon x minus 1 dx minus 2 integral 1 upon x plus 2 dx and plus 11 by 4 integral 1 upon x plus 3 dx. All the integrals here are of the form 1 by x, and their answer is nothing but log mod of the function in the denominator. So I can go to write 1 by 4 log mod of x minus 1 minus 2 log mod of x plus 2 plus 11 by 4 log mod of x plus 3 plus c. There is no further simplification advisable, so we'll keep it as it is. That's our final answer. Now we have seen how to evaluate when there are three terms in the denominator, how to find the rational coefficients a, b and c. Let's take one example for homework. Now this is on the same lines. You'll have three unknowns a, b and c in the partial form. Find them, integrate it. That's all we have in this module. Thank you very much.